Welcome back, my dear friends, in another video of the control engineering. We were discussing about the root locus. Today I will discuss the most important problem as per a video examination, which is the 20 marks question. So let us take here. For g of s, h of s is equal to k upon s into s plus 3 s plus 5. Draw the root locus. In the previous two problems we didn't draw the root locus over there in the graph sheet. So in this particular problem we will try to draw the graph. It is the most important question, right? So determine for damping ratio zeta is equal to 0.6. These specifications we have to calculate. Closed loop, dominant pole is dampened natural frequency, gain k. Later on I will tell you these terminologies, right? First of all, you have to understood the basic equation. So g of s is equal to k of s 1 plus t of t1s 1 plus t2s 1 plus 2 zeta upon omega n s plus s square by omega n square divided by s into 1 plus tas 1 plus tbs 1 plus 2 zeta omega n times s plus s square by omega n square. This is the main equation which you should remember, and also I will discuss the terminologies what these terms are over here. Okay, so 1 plus t1s 1 plus tas 1 plus t2s 1 plus tbs, like that you have to remember this, and this term will remain same. The terms in the numerator are called the zeros and the terms in the denominator are called the poles. So this k of s is called the, wherever you get this s after the k, this is called 0 at origin. Okay, if you get s in the denominator, it is called as pole at origin. First of all, let us what we call as discuss the terminologies in the numerator. This is called 0 at origin, this is called simple 0, this is also called simple 0, this is the complex 0. Okay, this is pole at origin, this is simple pole, this is again a simple pole, this is complex pole. These are the terminologies which you have to remember, so further you will get clarity in the problem itself. Okay, you have to remember these terminologies, like that I have written here. I have told you these terminologies, you can refer. Okay, so now in order to solve the root locus problem step by step, okay, first of all, to find poles and zeros, as I mentioned, what are the poles and zeros? The terms in the numerator itself are called zeros and the terms in the denominator are called poles. Now you have to calculate the number of poles. So in this problem, given problem, you have to find out the poles. Dear friends, the function is given, okay, k upon s into s plus 3 into s plus 5. So how many poles are here? This is called as pole at origin. I have mentioned it here. S is equal to pole at origin, that is pole at origin, one pole. S plus 3 is simple pole, s plus 5 is again a simple pole, that is 3 poles are present in this particular function. So I have written here the number of poles is equal to 3, right? So then number of zeros you have to check in the problem. Number of zeros, that is there is no term s term in the numerator, so no zeros are here. You can write down the number of zeros, z is equal to 0. Now poles are 3, but what are the values of poles in this particular equation? So you can write down, see here, s into s plus 3 s plus 5, you have to equate these equations to 0. So that is s is equal to 0 and s plus 3 you have to equate to 0, you will get s is equal to minus 3, and also s plus 5 is equal to 0, you have to what we call as transfer 5 on the right hand side, you will get minus 5. So these are the values, minus 5, minus 3 and 0, right? I have written here, that is 0, minus 3, minus 5. So this is the very first step in the root locus problem, finding out poles and zeros. Next, step 2, to find branches, that is n. Number of branches is always equal to poles when poles are greater than zeros. So in the above problem, poles are 3 and zeros are 0, no zeros are present, means p is greater than z. So p is greater than z means number of branches are equal to p. So n is equal to z will be only when z is greater than p, but in this problem number of branches will be p. Later on I will discuss the what are the branches and what is all about what we call as branches, so where it started, so I will tell it later on. So number of branches n is equal to 3 in this problem, which is equal to p, so that is 3. Number of branches terminating at infinity is equal to p minus z. Always remember, now I will discuss. So branches will always start from poles and will terminate at 0 and infinity. make a note of it, my dear friends. Branches will start from the poles, always start from poles and terminate at 0 or infinity. If there are 0 poles, right? If there are 0 poles, then I cannot say that branches will start from poles. I can simply say branches will originate at infinity, then terminate at 0 when poles are 0. So you have to remember this point. Branches always start from the poles and terminate at 0 or infinity. So number of branches terminating at infinity, there is a formula, p minus z, means poles minus zeros. So how many poles are there? 3 poles are there and 0 are 0. So p 3 minus 0 is 3. So number of branches terminating at infinity will be 3. So starting points of branches is equal to, means branches will always start from the poles. So what are the pole values? 0, minus 3, minus 5. So 0, minus 3, minus 5 are the starting points of branches. And ending points of branches, is there any 0 present? No. So I have told you these branches will terminate at either 0 or infinity, but here no zeros are present, so that is why here ending points of branches are infinity, 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 right? I hope you are followed. Then I hope you are following. So step 3, segment belonging to root locus. This is the third step, means you have to take these values 0, minus 3, then minus 3, minus 5, minus 5 and infinity you have to take. No values are there, so minus 5 and infinity. So first of all, let's take 0 and minus 3, between 0 and minus 3. So I am taking here the s plane, that is nothing but real and imaginary axis plane. This is called as s plane or complex plane. So you are taking 0 and minus 3. 0 and minus 3 are the pole values. Poles are always what we call as represented with the help of these cross, right? So pole representation is this and 0 representation is this one, right? So cross you have to take for poles and 0 for 0. Okay, so 0 and minus 3 are poles, so just draw the cross, and also minus 5 as the pole, so take it as cross over here. Okay, so between 0 and minus 3, draw the one breakaway point. It is called as breakaway point. So draw this point, and just arrowhead will be on the right, towards the right half of the s plane. It should be the right to the s plane over there. Okay, so whenever I am taking 0 and minus 3, in between 0 and minus 3, so on the right half of this direction, how many poles are present? One pole you are seeing here on the right side of the s plane. Okay, so one pole is present here. I can write the formula is np, number of poles and number of zeros, is equal to, number of poles is 1 here and zeros are nothing in this problem over here. Okay, so I can take 1 plus 0, so that is 1. If I am getting in these two poles, I am getting the odd number, so that means root locus exists in this particular these coordinates, these poles 0 and minus 3. So root locus exists here. Why? I am getting the odd number. If I am getting odd number, that means root locus exists. Next, between minus 3 and minus 5, so another I have to take minus 3, minus 5. So np plus nz, number of poles. So if I draw the breakaway point, on the right side I have to take the poles. So on the right hand side I am getting two poles, 1 and 2. So number of poles is 2, plus number of 0 is not present in this. Okay, so 2 plus 0 is 2. I am getting even number, so no root locus exists in this in these two poles over here. Okay, then I have to take another one, minus 5 to infinity. Okay, so in minus 5 and infinity, draw the breakaway point. It should be towards the right half of s plane, or towards the right of s plane, right? So you have to check the poles, how many poles are present towards the right. 1, 2 and 3. Okay, that is why I have written here, between minus 5 and minus infinity, np plus nz is equal to 3. Number of poles is 3, plus 0 is equal to 0, is equal to 3. So I am getting odd number again, that is root locus exists in this gap also, that is here root locus exists. Okay, so you have to mark this is the third step. Now for the fourth step, angle of asymptotes. What are the angle of asymptotes? As I have earlier told you, the branches will start from the poles and terminate at infinity. So the angle at which it terminates at infinity, so that angles you have to take in this particular diagram. Later on you will better understand in the, when I draw the root locus on the graph sheet, you will better understand how this, what we call as asymptote, angle of asymptote, what does this angle of asymptote mean, in which direction we can take it. Okay, so you have to take angles here. So it is formula is here, theta is equal to 2q plus 1 into 180 upon p minus z, where q value is 0 1 2 and p minus z minus 1 is the last value of the q over here. Okay, so in this problem, if I take q values, so p is given, number of poles is 3, minus z is 0 minus 1, 3 minus 1 is 2, so up to 2 I can take the q values, that is 0 1 2. Just because p minus z minus 1 I am getting here as 2, so I will take up to 2. Q is equal to 0 1 2. If you are getting 3 values of q, you have to take 3 thetas. Okay, so theta 1 is equal to 2 into 0, that is 0 plus 1, 1 into 180, that is 180 divided by 3 minus 0 is 3, 180 divided by 3, you are getting 60. Like that you have to calculate, then again you have to put one value, then two value, you are getting theta 1, theta 2, theta 3 as 300. So these angles we have to plot in the root locus graph over there. Okay, next step is fifth step, the centroid. Centroid is equal to real part of poles minus summation of real part of zeros, summation of real part of poles minus summation of real part of zeros upon p minus z. This centroid, why we have to calculate, just because we have to draw these angles, so only you can draw from this centroid only. Okay, you have to take centroid value, then you can plot these angles, 60 degree, 180 degree, 300 degree. Okay, so this is the fifth step where you have to calculate centroid. So sigma is equal to real parts of poles, means we have already the values of poles, that is 0 minus 3 and minus 5. So simply addition of these, 0 minus 3 minus 5, just because value is minus 3 for the pole and minus 5, so 0 minus 3 minus 5 into minus summation of real part of 0, zeros are not present, that is why I have taken 0 upon 3 minus 0, that is pole minus zeros, is equal to, when you just add it, it will become minus 8 upon 3, so you will get minus 2.67 as sigma value. So sigma is equal to minus 2.67. okay, so this is the centroid value. Now step 6 is breakaway point. A breakaway point is always existing between the root locus, between the two poles. There will be always a breakaway point which you should calculate. So in this breakaway point, you have to take the characteristic equation again. 1 plus g of s h of s is equal to 0. This is 1 plus k of g of s h of s is given in the problem, that is k upon s into s plus 3 s plus 5. Okay, so you just multiply it. This is s into s is s square plus 3s, s square plus 3s, and s plus 5 is same. I am just multiplying it with 1 here, plus k into 1 is k. This is denominator, I am shifting to the right hand side, it will become 0. So s cube plus 8s square, 8s square plus 15s plus k is equal to 0. So k I am taking here, k is equal to, these all terms I am shifting on the RHS, it will become minus s cube minus 8s square minus 15s, so is equal to this k. So then you have to differentiate this k with respect to s, so dk by ds is equal to 0, you have to take equation. So if you just differentiate this term with respect to s, so you will get minus 3s power down, and this will get minus 3 minus 1 is 2, so 3s minus 3s square minus 8 into 2, that is 16s minus 15s, differentiation is 15, is equal to 0. Now you have to calculate the roots of this equation, so you can use calci to calculate these values. Okay, so let me show you how to calculate this value. So you take the polynomial equation, so menu alpha a polynomial equation you have to take of second order, it is the 3s square, so I am taking 2. So what is the s square value? Minus 3. Minus 3 is equal to, x value is minus 16, right, is equal to minus 15, is equal to I am getting this value x1, so I am taking it in the decimal form, I will get minus 1.2137, so minus 1.2137. Then again another root, that is this one, so I will take minus 4.11 is the another root. Now I have to check the validity of the roots, which root is valid, which can be further employed in the problem. Let us see, dear friends, which is the valid. It depends upon the root locus, where the root locus exists. So see here, minus 1.2737 is existing between 0 and minus 3, right, so value is minus somewhere here, minus 1.2137, so their root locus exists. That means wherever the root locus is exist and the root value is existing between these two poles, so that is the valid root. Now minus 4.119 exists between minus 3 and minus 5, but we have already checked between the minus 3 and minus 5 no root locus exists. So I can say that this 4.1196 is in the no root locus zone, so we have to invalidate. This is the invalid root. Only root is invalid, that is 1.2137. that is your breakaway point, right? I hope you are getting. So this is the sixth step. Now seventh step is nothing but to find intersection with the imaginary axis of what, that is crossover point. You have to check, means the branches start will be at poles. So whenever I just proceed those what we call as branches to the infinity, it will be crossing the imaginary axis, as in the graph itself you are seeing here. When this touches this imaginary axis, okay, so we have to check this intersecting point, what will be the intersecting point of this, right? So to find intersection with imaginary axis, solve characteristic equation using Routh's array, where this you are getting already here the characteristic equation. See here, this is s cube 8s square plus 15s plus k is equal to 0. You have to take this equation only, s cube plus 8s square plus 15s plus k is equal to 0, right? So take in the highest order first of all, sorry, descending order. You have to take first s cube s square s1 s raised power 0, okay, like that. So what is the coefficient of s cube? 1. And you have to take first, if you have taken s cube, that is the odd term, so another odd term is s raised power 1 here, okay. So what is the coefficient of s raised power 1? That is 15. You have to check first the odd values accordingly, okay. Then I take s square. What is the s square coefficient? 8. And another s is not present. I can simply write here s raised power 0. Anything raised power 0 is equal to 1, which will not affect the equation. So what is the s raised power 0 coefficient? That is k. So I have calculated here. Now in order to get s raised power 1 here, you have to multiply these two terms, okay. 8 into 15 minus k into 1 divided by this 8 term. In simple terms, I will tell you, a b c d, if you have to calculate this e value, just multiple c into b minus d into a, b into c minus d into a divided by this c, you will get this value, okay. So same here, 8 into 15 is 120 minus k into 1 is minus k divided by this 8 value, okay. Now this term if you have to calculate, so you have to multiply this term with this term with this. Here is 0, here is no term, here is also no term. K into 0 is 0, 15 into 0 is 0, so here I have written 0, okay. Next term is, you have to multiply this term with this and this divided by this term, okay. You will get this term. So let me show you how you will get this value over here. So this is 120 minus k, 120 minus k upon 8. You have to multiply with k into k, right? Then 8 into 0 is 0, minus 0 I can write, divided by this value, that is 120 minus k upon 8. So this 120 minus k upon 8, 120 minus k upon 8 will get cancelled. I will get k only, so I have written here k. I hope you are following this Routh's array criteria over here. So for the stability, you have to just equate this to 0. 120 minus k divided by 8 is equal to 0, so that you will get k value. 8 into 0 is 0, so minus k I will shift on the right hand side, so that is k equal to 120. It is also called as k marginal. K marginal is equal to 120. If you just put this k value as 120 here, you will get 0. If you put 121, you will get in minus. Minus should not be in the Routh's array criteria. If you change, if the sign gets changed, the system will get unstable, okay. So that should not happen in this case. So what is the range of the k value? Greater or equal to 0, less or equal to 120, not greater than 120, just because the system will become unstable if the sign changes. So use auxiliary equation above row of zeros. Row of zeros means if you put k value as 120, it will become 120 minus 120 is 0. So 0 and 0, this is the 0 row. Above that, the equation above the 0 rows is called as auxiliary equation. So equation above row of zeros, that is s square. Here equation is auxiliary equation with the value of k. So write down auxiliary equation is equal to, equate it to 0. What is the auxiliary equation? 8 times s square, 8 times x square plus k is here, okay. So k is equal to 0. So 8s square is equal to minus k, S square you will get minus 120 by 8. When you calculate this term in the calci, S is equal to, you will get what we call as irrational number, plus minus j times 3.873. okay, this is your crossover point. It is also called as crossover point. Crossover point. Last part of this problem is plotting the this root locus, but before that, step 8 is angle of departure. But in this problem, angle of departure is not necessary to calculate. Why? In the problems, if you are getting complex poles and zeros, but in this problem, dear friends, I have told you, in this problem there is no complex pole, no complex zero. That is why we don't need to proceed for the angle of departure. But in some problems, if you are getting what we call as complex zeros or complex poles, then you go for the angle of departure. But in this problem we will not use it. So last step but not least is the plotting of root locus. So root locus plot, you just take the real part and imaginary part. This is your real axis, this is your imaginary axis, minus j, this is plus j, or plus I you will take, or plus minus j. So you have to now plot accordingly. So write down the minus 1, minus 2, minus 3, minus 4, minus 5, whatever the values you will take, up to minus infinity you have to take. Okay, so this is your minus infinity, this is your positive infinity, right? So I have taken here. Now first of all, where from we start the root locus to be drawn over here. So you have already got the value of sigma. You have to start from sigma value. What is the sigma value? Minus 2.67, right? So check here, this is your minus 2.67 is here. Okay, this is your sigma value. Now after that, the angle of asymptotus, what you are getting the angles. So angle of asymptotus we have already calculated, 60, 180, 300. Okay, from this only, from this centroid you have to draw the angle like 60 degree in this direction. So first of all, let me show you how to draw. So take the set square here, protractor. So mark the angle 60 degree, then 180 degree is on the real axis, then 300 degree in this direction. So from the centroid only you have to draw these angles. This is 270, 280, 290, 300 angle you have to draw in this direction, first step. Then the breakaway point which we have calculated already. What is the breakaway point? 1.2137, that is the valid root also. So minus 1.2137, somewhere here you will get minus 1.2137 somewhere here. Okay, and also crossover points we have calculated, that is plus minus j times 3.873. so mark it here, 3.873 and minus 3.873. okay, somewhere here in the negative direction, but it is in terms of j. okay, this is the imaginary axis. J you have to take already here, see, j 3.873, mark here. Now draw the smooth curve from this point, that is minus 1.27, that is the breakaway point. Start a what we call as free curve and draw up to this point, crossover point. okay, then you have to draw this line parallel to this one. okay, so this line you have to draw parallel so that it will never meet again with each other, or it will just go through the infinity also. So you can draw this line parallel to this one, okay, previously drawn. So this is the third point. Now another point is important one, that is quantities of interest. Means in the question some some quantities we have to calculate. At zeta is equal to 0.6, it is mentioned in the question. At zeta is equal to 0.6 we have to calculate closed loop dominant poles. Closed loop dominant poles. See here, so theta is equal to cos inverse of zeta is the formula. So theta is equal to 53.13. you have to draw, mark this in RLP from root locus pole from negative real axis. Means in the negative direction you have to draw 53 degree angle, that is your theta. In the question it is mentioned theta is equal to cos inverse of zeta is the formula. You have to calculate theta. So I am getting with 53.13 in the clockwise direction, right? Now from point P, dominant pole, just it is meeting this curve at this point, right? So just draw the straight line. It is meeting in the imaginary axis here and also here at -1. So it is what we call as coordinates will be s is equal to this -1 and this will be 1.25. if we just measure it, or if you just measure it, right, this is the minus 1.25 somewhere here. So just write minus 1 plus minus j 1.25 will be your dominant pole. This is called as dominant pole. Then characteristic equation for this, it is plus minus, so I'm taking 2 times s plus, first of all minus 1 I will shift here, it will become plus 1. This minus I will shift here, it will become positive j of 1.25. And another one will be s plus 1 minus times 1.25 is equal to 0. This is the characteristic equation. So s square, s into s is s square, s into 1 is s into this j is minus times 1.25 s, okay, and j plus this 1 into s is s, 1 into 1 is 1, 1 into minus j is this minus j point 1.25, right, plus this j 1.25 into s is j 1.25 s plus this j 0.125 into 1, it will become this term, minus j into j is j square into 1.25 whole square is equal to 0. You will get this term and this positive will get cancelled, this and this will get cancelled, okay, sorry, this one and this one and this and this. So s square plus this s plus s is 2s plus 2.5625, you will get value over here j square, by putting j square is equal to minus 1 and square of this 1.25 square, you will get plus times 2.5625 is equal to 0. This is the characteristic equation formed for this dominant pole, okay. Next you have to compare with the standard form. Standard form for the dominant pole is s square plus 2 zeta omega ns plus omega square is equal to 0. This is the standard equation for dominant pole, but we are getting here the standard equation as s square plus 2s plus 2.5. so compare the accordingly terms. So s square is here, s square is also here in this equation, okay. Now second term is 2 zeta omega ns, it will be equal to the second term of this, that is 2s. Another one is 2.5625 will be equal to this omega n square. So I am taking here omega n is equal to under root of that particular value, that is 2.5625, which is equal to 1.6 radian you will get. Then omega d, that is damped frequency, it is in the question, you have to calculate damped frequency, not the natural frequency. So it is equal to omega n natural frequency into 1 minus damping factor, that is 1 minus zeta square. When you just put the values in the calculator, you will get 1.28 radians per second, okay. Now another one, you have to calculate the gain k, it is also mentioned in the problem, dear friends. So k value you have to calculate, sorry, here gain k. So how to calculate, you just take magnitude condition, it is always equal to 1, g of s h of s is equal to 1. So modulus of k upon modulus of s plus 3 modulus of s plus 15 is the given function. At what value s is equal to minus 1 plus minus 1.25, j is equal to always 1. So you have to put this s value as minus 1 plus 1.25, whatever you will take, minus or plus, you will get always positive just because it is modulus. So just put these values in the calculator, you will get gain value k is equal to 15.822. so this is all about this problem. I hope you have understood these concepts very well. So make sure you will comment down if you are understanding, if you have some problem in this particular concept, so you can comment down so I can tackle that. And also share this video to your all friends who actually need it. Thank you for watching my video.